Okay, here we are with the Unit 6 quiz/review. Hopefully all of you get this tonight and make necessary fixes and changes to your quiz and turn it in tomorrow and get the best grade possible. Hopefully helps you review and learn how to review for a math test, okay? That's the most important part here. Those are the topics that we're going to take a look at in that order, so if you need to fast forward to something in particular, feel free to do so. All right, and let's get started then. Graphing first, okay? And looking at this, we have graph f of x equals -2 cosine pi over 3, quantity x plus 1 minus 3. First, it asks us to state all of those sort of shifts or transformations. So the amplitude is 2, okay? The frequency is pi over 3, and that will help us find the period. Horizontal shift is left 1, and the vertical shift k is down 3. PB equals 2 pi is the equation we use to find the period when given frequency. So P times pi over 3 equals 2 pi. Pi's on each side cancel. 3 times 2 is 6, so our period is 6. So when graphing this sinusoidal function, first of all, you don't have to do it this way, but I would plot a new x-axis because that's what our curve will cycle around. So it's just a good visual to try to look at and see, is that splitting my graph in half? Okay, then I try to plot the first point. So normally cosine would begin one above your x-axis, but in this case, we've been moved to the left one, and our amplitude is 2, but it's a negative, which means we start at a low point, at a minimum value for our first point. So we always graph the first point first. The next point we graph is the last point, which will be 6 away. Sorry about that, little phone call. So we always graph the first point first, and then I always tell you to graph the last point next. So if the period's 6 what? Well, 6 blocks in this case. 1, 2, 3, 4, 5, 6 blocks away is the last point for cosine, which is the same as the first point. That's how these graphs work. Okay. So if those points are minimums, the halfway point between them will be a maximum, and that'll be 2 above your x-axis. And then halfway between these 2 points will be your x-intercepts for cosine. And again, that's something that you should have hopefully in your toolkit, what those 5 points are for the 5-point graphing method. And then you can continue that graph, all right? 6 more. Okay, halfway, halfway, halfway again. And you can continue that graph as many times as you want because it does keep cycling. Now obviously 1 cycle is necessary for full credit. Okay, next we have, write the equation of a sinusoidal function. It has a minimum at -4, 1 and a maximum of 111. If you have those 2 points, you have enough. Okay, so let's take a look at this particular function, -4, 1. So right here is -4, 1. That's a min. And then 1, 11 is the next point. So what you got to ask yourself is how far away are those 2 points? They're 5 away from each other. Okay, there's 5 x values in here. So we go 5 more x values to get the next minimum, which will be at 6. Okay, and then you can draw a curve if you'd like, and that's all we need. All right, this particular curve is starting at a min, which tells us negative cosine. That's the only one that starts at a minimum. And then we find all of our other values, a, b, h, k, and period. Okay? And some of these are observed, like the period is observed. How far is it from the first point to the last point? It's 10. Okay? What is the horizontal shift? That's observed. It is left 4, so it would be plus 4. The rest of these we need to calculate, and you have equations for that. Amplitude, okay, the amplitude here will be the max minus the min divided by 2. So 11 minus 1 is 10, divided by 2 is 5. The vertical shift will be the maximum plus the minimum divided by 2. So that's 11 plus 1, which is 12, divided by 2 is 6. So up 6 will be your k value. Okay. And then b is also calculated pb equals 2 pi, so 10b equals 2 pi, which means b equals pi over 5. And we write our equation. So y equals negative 5 cosine pi over 5 times the quantity x plus 4 plus 6. Next, we have a couple problems here. All right, and taking a look at this, evaluate these expressions using angle sum or difference formulas. So sine of 255, we're trying to look for two angles that when you add them together, you get 255. All right, so I'm looking at this and I'm thinking maybe 210 plus 45. And the sum identity for sine will be sine of 210 cosine 45 plus cosine 210 and the sine of 45. Okay, and the sine here of 210, that's in the third quadrant. That's on your unit circle. Okay, the sine there is negative 1/2. The cosine of 45 is root 2 over 2. Plus, the cosine of 210 is negative root 3 over 2. And the sine of 45 is root 2 over 2. And then we simplify. So negative root 2 over 4 plus negative root 6 over 4, and if I add those together, negative root 2 minus root 6 all over 4, and that cannot be simplified any further. Okay, next we have the cosine of negative 75. You have a lot of ways you could go about finding this one. You could add two values together where the negative value is bigger than the positive value, or you could subtract, okay, to find this one. And honestly, it doesn't matter to me. How about the cosine of negative 45 plus negative 30? Okay, so the only thing we got to remember there is that negative 45 degrees is actually 315. And negative 30 degrees is actually 330. So we're actually looking at 315 plus 330. So we'll have cosine of 315, cosine of 330, minus sine 315, sine 330. Okay. These are all in the fourth quadrant, which means cosines are positive, sines are negative. So cosine of 315 is root 2 over 2. Cosine of 330 is root 3 over 2. Minus the sine of 315. These will be negative now. It's negative root 2 over 2. And the sine of 330 is going to be negative 1/2. So I end up with root 6 over 4 minus root 2 over 4. So, whoops. That simplifies to just root 6 minus root 2 all over 4, and that cannot be simplified any further. Obviously, there's many other ways to do this. That's the way that I chose. All right, find the exact value of sine of x minus y if sine is negative 3/5 and in quadrant 3, and cosine is 5/13 in quadrant 1. So pictures here usually help. You don't have to have them, but they do help. So if sine is negative 3/5, that means y is negative 3, hypotenuse is 5. That means our cosine value here is negative 4, Pythagorean triple. Cosine is 5/13 and it's in quadrant 1. So that means our x value is 5. Our hypotenuse is 13. Again, another Pythagorean triple. Our y value is 12. So sine of x minus y. So here's x, here's y. So we have the sine of x and the cosine of y minus the cosine of x and the sine of y. We're figuring out the sine, or determining the sine of x, cosine y, so on and so forth from each triangle. So the sine of x will be the sine of this triangle, which is negative 3/5. Cosine of y would be the cosine of this triangle, which is 5/13. Minus the cosine of x, that'd be this one right here, negative 4/5, times the sine of y will be 12/13. Okay, and then I simplify from there. So I end up with negative 15 over 65 plus negative 48 over 65, and then I add those two together, so that gives me negative 53 over 65 as my final answer. Okay, let's scroll down here, try some more. On to the next page. Come on. All right, so now solving some trig equations. So we have, and these are just like solving equations that you solved in algebra. We're trying to isolate the x value. The thing here is sine is actually more powerful than exponents. It sort of like falls in with parentheses, I guess. So it's what we're going to do last. So we're going to subtract 3 first from both sides. So root 2 sine of x equals negative 1. Divide by the square root of 2. So we get the sine of x equals negative 1 over root 2. Now here you have a choice. You could rationalize this, but you don't have to. When you're trying to solve for an angle, we do inverse sine. So the next step here is just to take the inverse sine of negative 1 over root 2. That's geometry. You should already know how to do that. The thing we do have to remember, though, is there's two answers that it's not from geometry. Sine negative would give us third and fourth quadrant for negative sine. Okay, so that means when we get an answer here, it's going to give us an answer in one of those two quadrants. We'll have to find the other answer. We may have to interpret this answer as well, because your calculator is probably going to give you negative 45 for this answer, but we want answers between 0 and 2 pi. So negative 45 would be this one right here, which is 315 degrees, all right, which would also be 7 pi over 4. Okay, so if that's 45, that means that's 45. So that means this angle right here would be 225, okay, or better yet, in radians, this angle right here would be 5 pi over 4. So the best answer for this would be 5 pi over 4, comma, 7 pi over 4. Okay, next one here, same thing, minus 7 from both sides, so negative 6 cosine of x equals 3, divide by negative 6, so cosine of x equals negative 1/2. So two answers for this. Where is cosine negative? Cosine's negative in 2 and 3. So we're looking at second and third quadrant. Okay, and negative 1/2, that's unit circles, so you don't have to do inverse cosine, but you could. All right, we know cosine is negative 1/2 at, let's see here, 120 degrees. Okay, and we also know it's negative 1/2 at 240 degrees. Now this says for all values of x, which means we're actually going to have an equation for our answer. So the initial value is 120, and then every 360 degrees we're going to get another answer. So 360 would be your growth. 240 is the initial value, and then every 360 degrees after that would be the next answers. All right, if sine of x equals 3/5, and that's in quadrant 2, find the cosine of 2x. So this will be double angle identity for cosine. So sine of x is 3/5 in quadrant 2, so we're in the second quadrant. Y is 3, hypotenuse is 5. Again, definitions that you have to have memorized. The cosine value there would be negative 4. That's a Pythagorean triple. Cosine of 2x equals cosine squared x minus sine squared x. That is not the Pythagorean identity. Be careful. So the cosine of x is negative 4/5 squared minus the sine of x, that was given, 3/5 squared. A lot of people say, how do I square, a cosine? Well, you just calculate the cosine, negative 4/5, and then square that answer. So we end up with 16/25 minus 9/25, which gives us negative 7/25 as our answer. Okay. And then we have the half angle identity for sine. So taking a look at this, if tangent is negative 5/12 in quadrant 4, so fourth quadrant, tangent is x5 over, excuse me, sorry about that. Tangent is y, negative 5 over x12, which means the hypotenuse is 13. That's another Pythagorean triple. The half angle identity for sine of x over 2 equals plus or minus the square root of 1 plus cosine of x all over 2. All right. Got that. Sorry. This would be minus 1 minus cosine of x all over 2. So I'm looking at my triangle there, and I'm determining whether it's plus or minus. Well, it's sine, and we're in quadrant 4, so it's negative square root of 1 minus cosine, which is 12/13 all over 2. So 1 minus 12/13 would be 1/13. So we have negative square root of 1/13 divided by 2. 1/13 divided by 2 is 1/26. So we have negative square root of 1/26. And if I rationalize that, I end up with negative root 26 over 26. And now we're up to the last two, probably the tougher two. Okay, so solve each equation for all values of x. So this is a quadratic, okay? And if it's looking at this is difficult to do, then what we can say over here is we say, okay, well, we have sine there. Let's say u equals sine of x. This is called u substitution. Okay? So basically, anywhere there's a sine of x, we're going to use the letter u instead. So this will be 2u squared minus 5u plus 2 equals 0. So if that doesn't look quadratic, then you've got to go back to algebra B and algebra 2. So how do I factor this? Well, I end up with 2u and u. And I could use my box diamond here if I need to. Okay, but what I'm looking for is when I multiply these two together, here and here, it needs to equal 2. Okay, so 2 and 1 are my only options. All right, but what has to happen there is when I add these two and these two together, it has to give me negative 5. So I'm going to go with a minus 2 and a minus 1, because negative 1 and negative 4 make negative 5. Negative 1 and negative 2 multiplied make positive 2. Zero product property says 2u minus 1 equals 0, which means u is going to equal 1/2. And over here, u minus 2 equals 0, which means u is going to equal 2. So once I get to this point, now I bring my sign back into it when things make a little more sense. So the sine of x, I just plug sine in for u, equals 1/2. I can solve that. Okay, x is going to equal, well, we're looking at first and second quadrant, and sine is 1/2. So x is going to equal, let's see here, 30 degrees plus 360n. Or x could equal 150 degrees plus 360n. You could do inverse sine here if you need to. And then over here, sine of x equaling 2, there would be no solutions because 2 is out of our range. The range is negative 1 to 1. So we end up only getting 2 answers. All right, if you need your answers in radians, it'd be pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. All right, over here we have 4 sine squared plus 2 cosine squared equals 3. So the only tricky part here is we have sines and cosines in the same equation. Anytime you have that, we want to get one of them. All right, so what I'm going to do is I'm going to substitute for cosine squared. And I know that by Pythagorean theorem, Pythagorean identity, cosine squared equals 1 minus sine squared. Then I'll have all sines. So 4 sine squared of x plus 2 times 1 minus sine squared of x. Okay, equals 3. So 4 sine squared x plus 2 minus 2 sine squared x equals 3. So the 4 sine squared and the minus 2 sine squared simplify to just 2 sine squared x plus 2 equals 3. So I subtract 2 from both sides. So 2 sine squared x equals 1. Divide by 2. So sine squared x equals 1/2. All right. Square root both sides. So sine of x equals the square root of 1/2. Okay. Which means I can do inverse sine of square root of 1/2 unless I know what that equals. And I do. It equals root 2 over 2. But if you're not comfortable with that, then you could just do the inverse sine of square root of 1/2 and determine that sine is positive here. So we're going to have answers in the first and second quadrant. And it looks like we're going to have 45 degrees plus 360n. The equivalent of that in the second quadrant will be 135 degrees plus 360n. Your calculator will give you one of those. You'll have to determine the other. Last but not least here is law of sines. That's geometry review. Okay, but we're going to go over, there's a lot of people ask about that in the closure. Okay, so draw a picture. Don't worry about drawing the picture of both triangles. Okay, a lot of people get confused when they try to do that. Okay, just draw one picture. So 34 degrees is angle A. Okay, side A is 7, side B is 12. So we have angle, side, side. Angle, side, side. That tells us two possibilities. Okay, so go ahead and list out all your angles, all your sides for both possibilities. I'll do the other possibility in an alternate color. A prime, B prime, C prime. Fill in your givens because they're not going to change. So 12 and 7, 34 degrees. Okay, 12 and 7, 34 degrees. Then go about your business. Find your first angle. So sine of 34 over 7 equals the sine of B over 12. Don't round to the very last step. So what you'd be typing in your calculator here is B equals the inverse sine of 12 times the sine of 34 in parentheses divided by 7. All right, make sure your calculator is in degrees. That's the only way you're going to get the answer you want here. Okay, so 12 times the sine of 34 divided by 7. All right, ends up giving me an angle B of 73.5 degrees. So that's my first angle, 73.5 degrees of case 1. Now, to get its alter ego, I take 180 minus that angle, and I get 106.5 degrees for my second case triangle. And then I just go and solve each of those separately. Okay, so back here to my original 73.5, okay, plus 34 degrees from, and subtracting that from 180, all right, ends up giving me 72.5 degrees for my third. That's the triangle angle sum theorem. Okay, down here, finding that third side, okay, or third angle, excuse me, I'll add these two together. So 106.5 plus 34, and then subtract that from 180. Gives me 39.5 for that missing angle. And then I go and find my missing side by doing law of sines again. So sine of 34 over 7 equals the sine of 72.5 over C. Same thing down here. Sine of 34 over 7 equals the sine of 39.5 over C prime. And I find each of those sides. And when I type those into my calculator and get answers, I end up with 11.94 for side C here. And that makes sense because 73.5, 72 are very close, so it's almost an isosceles triangle here. And 12 and 11.94 are very close. Okay. Down here, I end up with 7.96, which makes sense because 34, 39.5 are very close. 7.96. Very close. Also, I can check to make sure that the sum of two of my angles is greater than the third, or two of my sides greater than the third side. That's triangle side inequality. Also, I can check that the biggest angle is paired up with the biggest side, smallest angle, and smallest side. There's both scenarios there for law of sines. And that is all. Hopefully you make all the proper corrections. Bring that paper stapled to the back of your original with all the problems completed correctly. and I will grade that in place of a quiz. See you tomorrow.